Good pre-noon, everybody, and welcome to another one of our cosmic conversations. My name is Josh. I'm a member of the staff at the Morrison Planetarium at the California Academy of Sciences, and we are super excited to be sending out to all of you another one of our Friday cosmic conversations. This time we are bringing in a very special guest from all the way across the country over in New York. That is Irene Pease. Now, Irene, you told us to introduce you as a friendly neighborhood astronomizer.
I do like using the word astronomizing. It's a favorite. But yeah, I go by Friendly Neighborhood Astronomer. So it's a website. I do some live streams and some visuals and other things in all my spare time.
That sounds like a really fun spot to fill. So what does a Friendly Neighborhood Astronomer do?
Well, usually I would have some kind of telescope out, like showing people stuff in the night sky. And yes, you can see stuff in the night sky from New York City. You can see planets, you can see the moon, some stars, satellites. But I also do like some visuals. I'm a Hayden associate. So for a while I was producing Hayden Planetarium video blog, which you can check out on their website. It's called Skylight. That's not happening right now. But yeah, working on some live streams and just sharing space with the rest of the interverse.
Well, we are delighted to have you here to share a little bit about the history of human involvement traveling beyond planet Earth and learning about it. What are we talking about today?
Right. So I just want to get off of the planet for a little while. That's kind of like my escape these days, is going into space. And we have like some kind of interesting anniversaries this month. So it's kind of a huge topic. So we're not going to cover everything, but just kind of stepping through a little bit of some of my favorite things in space history, and starting off with kind of what launched a lot of this way back, totally different political climate, but the space race. So overhead, we see this little thing moving across the sky. Just on October 4th was the anniversary from October 4th, 1957 of the Sputnik launch. So it was a little terrifying at the time. But I mean, basically, the Soviet Union launched a basketball, beach ball size thing into space. It orbited the Earth. So that was like our first artificial satellite, which, as far as like space exploration goes, is pretty exciting, pretty monumental. So obviously, we're not looking at Sputnik here. This isn't round. This is a little beach ball. You can actually see the shape, and some people might even recognize it as the International Space Station. But that's kind of what it would have looked like in the sky. So even tonight, like you can see, if you have a clear sky, you can see like little dots moving across the night sky, like after sunset or even just before sunrise. We have a lot of things up in space right now, but it kind of started off, Sputnik 1. So a lot of things in orbit, but I do want to talk a little bit about people in space. So we're going to fast forward a little bit.
Sure thing. Let's head out to the ISS.
Yeah. Oh, so a lot of other space stations have been up there. So the Soviets had their Soyuz program. There was Skylab back in the 70s. Mir, of course, Mir was actually inhabited continuously for almost 10 years. And then at the end of its tenure, we were building the ISS. So as Josh is bringing us in there, we can see it's grown since 1998. It's expanded a little bit. But even in there, you can kind of see the first piece that still has like its little remnants. It was all self-contained, the Zarya unit that the Russians put up there. So again, they had a lot of experience with Mir and their other previous programs. So kind of that side off towards the left, as we're seeing it, is kind of the Russian side.
There. For folks who are looking from home, the way I'm distinguishing it is it kind of looks like a tube of toothpaste. You've got the collar there and the body behind it, but it's got an interesting tapered shape to it.
And you can see even like the Soyuz rockets, the Soyuz vessels kind of parked there, in case you need to escape, in case you need to get out. But yeah, that side is still kind of like the control side. And then the other side on our right is kind of built up. So the next piece off to the right, that was the first US piece. My notes, the Unity. Then we have way at the end, the kind of long thing sticking off there. At the bottom, you have the ESA piece, and the other piece is or did I flip that? The other piece is Japan. So mostly like labs there, but really incredible how it's kind of built up over the years. And I mentioned there were multiple anniversaries this month. As of October 31st, so just coming up in a couple weeks, the ISS will have been continually inhabited for 20 years. It'll be like the 20-year anniversary of people living in space. So just thinking about that, I'm like, we live in the future. There's people in space, like, and there's a planet inhabited entirely by robots that we might get to. So kind of amazing. But yeah, so you can see that in the night sky if you're looking out. There's like apps and stuff where you can figure out when it's going to be flying overhead at your location, because it's kind of localized as far as sightings. So that's only like a few hundred kilometers or a couple hundred miles, but people have been further than that, right? So people have been all the way out to the moon, which is about 240,000 miles, so a little further away. And kind of some of the first people. So I'm not going to go through all the landers and everything, but just some of the like people on the moon. So where have we gone as a species in person? And kind of the first trip around the moon, not landing on it, but around the moon, 1968, late 1968, right around Christmas. So it was like Christmas Eve. There was the Apollo 8 mission. So it was also the first mission where we actually put people on top of a Saturn V rocket. So those were some very brave souls to do that and launched off successfully, obviously. But they had this amazing view where they flew around the far side of the moon. So since the moon is tidally locked, one side faces us and the other side we don't get to see unless you're, an astronaut and you fly around to the other side. So we have maps because we've had orbiters and other things, but these were the first people to really actually be there and see it for themselves. So, they're kind of like way out there, other side of the moon. You can't really communicate with Earth because, the moon is in the way at that moment. And, just looking down and seeing this really cool view. And I think they didn't really expect to see the Earth the way they did. Like some people have said, we went to space and we kind of rediscovered Earth in a way. So seeing what we call, probably a lot of people have seen the image that we call the Earthrise, that was taken by these Apollo 8 astronauts, was kind of a big deal. So this is our module, right?
This is indeed. I'm looking around, checking the limb of the moon, see if I can spot our planet Earth. I thought I had it all lined up. But for folks, there we go.
Oh, there we go.
For folks who are checking this out from home and you want to try out some of the same stuff, we are using the open space software from the openspaceproject.com. And if you were to load it up on your computer and plug in this date, you can see down here is Wednesday, 25th, 1968 at 6:20 55, let's call it 21 GMT, you could see the exact same view from your home computer. So if this is a cool looking thing to you, by all means, go check it out.
So definitely you don't really have it Earth rising or setting for most of the moon, right? Again, because it's not rotating. Well, it's rotating once per revolution, but so the same side is facing us. But when you're kind of on that edge between the near and far sides, and it'll actually like wobble above and below the horizon. But just kind of a really beautiful image. And I was actually just on a call earlier today, and someone was talking about how it was with this kind of the advent of us being able to see the Earth from space that we started actually putting clouds on the planet. Like before that in sci-fi, you don't really see clouds. You just see like, oh, it's like blue and green. But it's like we really started considering our atmosphere and becoming a little bit more environmentally aware around this era. So that was the first time people went around the moon, but we had some people landing on the moon. And I don't know, Josh, do we have a minute or two to stop by one of those sites, or maybe just view from space?
So I can jump us forward. We're going to jump in time several years and then go look down onto a very special part of the moon. We are going to go see the last time human beings set foot on the moon.
It was a while. It's been a while.
Yes, indeed. Coming up on 50 years.
Almost 50 years. So between 1969 and 1972, right? There were 12 American astronauts that walked on the moon. So 6 different landings, 12 people. And the last one was the Apollo 17, which landed kind of between, I guess it's off the Sea of Serenity, kind of between Serenity, Tranquility, over in the highlands there. So kind of an interesting site. Apollo 15 is one of my favorites, but it's like kind of in the middle. So we're like, let's just do the last one. But 15 was the first to have a car. So I'm like, what's more American than bringing a car to the moon? So 15, 16, and 17 all had a rover. It was more of a rover. I call it a car, but it was a rover. Kind of like these electric vehicles that the astronauts could use to get a little bit further from their site. So even though there's like less gravity, it's still like hard moving around in those suits because, you know, you have your whole life support system on your back. So it's a little unwieldy. But they were able to kind of rove around between kind of these two mountains, kind of like, I think it was like 5 miles off in one direction, a little ways off in the other direction.
We can actually see some of those if I tilt us down.
See the maps. So we have amazing maps. I don't know if you can tell us a little more about how we got these maps, or what kind of resolution we're looking at here. It's pretty high resolution.
Pretty impressive resolution. So you can actually see, if I get us a little bit of an angle, these dark lines across the surface. That's not a weird artifact or like someone drawing on it later. These are actually the footprints and tracks left by astronauts moving around on the surface. You can tell exactly where they went. By comparing some of the images that were taken from the surface, we can locate specific things down to like the meter or so of where we know that they were left, which is pretty impressive. And I just want to tilt us up. We're all very familiar with like shots from the moon in the planetarium industry, but seeing these things laid out in front of us and just the topography of the area around them, and even the module in context based on some photogrammetry that was taken of one of the actual ones here on Earth, it's just recreating this in a really beautiful, really special way.
And I mean, the landscape there, I mean, the moon has some relatively extreme landscape. I mean, there's less gravity, so it just has these huge mountains, huge craters. I think I was hearing someone say one of those mountains, it was North or South Mountain. So we just saw a North Mountain, and I think we're panning around, we'll see South Mountain across from it. I don't remember which one is like actually higher than the Grand Canyon is deep. I mean, just like huge stuff. I mean, oh yeah, that looks like a big mountain.
That's big.
That's big. And I mean, I'm not even there, but I'm like, yeah, definitely a big mountain. And remember, the lunar horizon is a lot closer because it's a smaller sphere. So even things that are on the horizon, they're bigger, even though they're on the horizon, because the horizon's a lot closer. So really beautiful. And of course, from the moon, you can look up and see the Earth in the sky, watch it go through phases. So if you ever, visit the moon, when we send people back, not if, but when, I'm going to say,
when, let's say,
we can look up and say hello. It's always going to be there as long as you land on the Earth side, the near side, as we like to call it. So that's as far as people have gone. That's it. It's 240,000 miles, but we've sent robots all over. So maybe can we check out some places where robots have been that we haven't yet? I'm just going to put a yet there.
So we're heading in much closer to the sun.
Okay.
Than we've been.
So we'll go kind of inner solar system. Ooh, very close. So this looks kind of like the moon, but not the moon. It's a little further away from us than the moon is. This is the closest planet to the sun, Mercury. So the first really great views of Mercury we got back in the early 70s from the Mariner. It was like Mariner, I wrote it down. One of the Mariner 10, I want to say. Mm-hmm. And it gets to get a flyby. So subsequent missions to Mercury, very complicated to actually get into orbit. But that flyby, we did get a partial map. And it got, I believe, at least half of that huge crater that you're seeing over on the right side. So that's Caloris Basin, which is like a huge impact. A lot of these planetary bodies have evidence of huge impacts from their past. So this was one of the really big ones on Mercury. It actually sent like shockwaves around to the other side of the planet. But yeah, so like half a map, and then we got our full map much later, like over 40 years later, when we sent the Messenger mission. And Josh is bringing up a really cool Messenger map. This is like some combined data. Is this like some of the mineralogy that we were able to get from spectroscopy?
And combined with some analysis of what the surface color would look like, exaggerated to a huge degree to give us that variation, but it's a way of representing a different view of Mercury than the one we're used to seeing of that flat gray.
Yeah. So Messenger orbited for a few years and got just like so much data about Mercury. It took like 7 years to get there, though. So when we shoot things into the inner solar system, they have to go faster, but then you have to like shrink your orbit. And so like it's complicated. Like you go around Earth and then you like do a couple of Venus flybys and you do like multiple Mercury flybys before you actually have orbit insertion. And so there's another mission on its way now, the ESA Bepi-Colombo mission, which is currently about to fly by Venus. So maybe we can just jaunt over to Venus, like you do.
It's nice to be able to just fly around the solar system. It's
so nice. Love my open space. So Venus has been in the news relatively recently. There was a possible biomarker, phosphine, and kind of exciting because Bepi-Colombo we thought might be able to do some follow-up. So I was actually just listening to a scientist the other night. We do Astronomy on Tap. They're all over the place. Look them up. But we had Astronomy on Tap NYC on Wednesday. And we had a scientist, Clara Souza Silva, who is kind of a leading expert on using phosphine as a biomarker. And she was like, yeah, with the Bepi-Colombo follow-up, even though they're doing a flyby, the instrument, it's going to detect infrared. And so that can't really penetrate very deep into the cloud. So she said, even if they get a good look, they're probably not going to be able to see much of any phosphine, if any, because it would be deeper in. But, we can take a look and, kind of test it out. So more follow-up needed, but very cool. The most successful missions, I would say, for Venus were the Variners. So Soviet Union missions, again, like back in the 70s. Venera 7, just like a year after we successfully put people on the moon, Venera 7 successfully landed on another planet. That was the first time anyone had landed on another planet. So some of the Veneers were more successful than others. 7 was the first one that was able to land and send back some data, and I think it was 12 was the most successful one that actually lasted just shy of 2 hours before it melted or got stuck.
Which is impressive on Venus. That's a tough environment.
Venus is way harsh. Yeah, very impressive. So I mean, like no one's even come close to that since then. But maybe we've mostly been looking outward towards Mars, but maybe there'll be a little more interest in Venus. So I think is this the height map that we have, the elevation map?
We've got a little bit of our topography on, and we faded down that impressive but view-blocking atmosphere.
Yeah, hard to see through those.
We had a great question come in from Christine. We've been throwing around some terms, metallicity and mineralogy. How would you define the difference between them?
Oh, for how would I define them? Probably not so well, but so metallicity, like I'm used to hearing metallicity like when we talk about like stars and like overall makeup of like a whole system. So how much stuff is there that is actual metals, or sometimes what astronomers call metals is just anything that's not hydrogen or helium. So heavier elements, I'll say, for metallicity. And then mineralogy, there I think you're putting your atoms together in certain arrangements and looking at certain actual minerals. Like, do you have silica? Do you have, some oxides? And looking at, more complex arrangements of your atoms, not just like what's the atomic mass of your atoms.
I'd say, in like a cosmological scale, we can learn a lot about the age of a star or even a solar system based on its metallicity. But a really cool way of thinking about mineralogy, it gives you more complex history on a rocky body. So learning about the mineralogy of Earth gives us a lot of insight into how Earth has changed over time. But for coarse strokes and cosmological strokes, metallicity is still really useful. Let's see. So we've done a little bit of visiting on Venus. I think we were planning on heading a bit farther out for our next.
Yeah, we're just gonna go all out. Just take us away.
Okay. So we are lining ourselves up for one of our farthest flung probes. Let's go check out Pioneer 11.
Woo, Pioneers. So we've sent out several probes to the outer solar system, and we're just going to kind of touch on a few of those. So the Pioneers, we did, 10 and 11 that went kind of far flung. So if we stop by 11, they were both launched like early 70s, so 72 and 73. And those actually had little plaques that had like kind of a little map of where we are, like using pulsars, like kind of like a map of like, I don't know if that was a good idea or not. That's debatable. We don't have to go there.
I don't think anybody's going to find it, so we're pretty safe.
Probably safe to broadcast our location to the universe. Yeah, no one will pick it up. But yeah, so here's one of our little Pioneers. So like nothing too complicated, basically like a satellite dish for communication and, to holler back, say, hi, I'm still here. This is how far away I am. This is what I'm seeing. But eventually getting to the interstellar medium. So beyond kind of the, we'll say, magnetic influence of the sun, and really just figuring out, like when we were sending these things out to some of the outer planets and then the outer solar system, we just didn't really know what was out there past the planets. But so Pioneer 11, that stopped by two of the outer planets, right? Jupiter and Saturn. So maybe we can just kind of take our bird's eye view.
Context.
Yeah. And see this really, really neat feature of being able to kind of step through time and like kind of watch these, watch the missions evolve, because it did take a while, right? So
for sure.
It took, like 7 years to get from Earth to like kind of deorbit into Mercury, but it took actually less time to get, I think, out to Jupiter. But then the outer parts of the solar system are much, much further.
So we've just teleported ourselves in time and space to put ourselves next to Pioneer 11, as we are getting closer and closer to many people's favorite planet, that is Saturn.
So beautiful.
So we're going to jump time forward significantly and give ourselves the ability to go through time very quickly. Let's see. I think our best option here would be starting off at normal time, where we're going 1 second per second. It's going to be a pretty quick approach because these things are going fairly fast. But rather than wait around for that, we can actually try 6 months per second, which gives us an impressively fast view.
That'll get us out
Saturn, zooming past Uranus.
Or at least the orbit of Uranus.
The orbit of Uranus.
Yeah.
And then the orbit of Neptune.
Yeah.
And getting farther and farther all the time. Now you can see a couple other spacecraft going with this spacecraft. I'm going to pause time again and go visit our Voyager 2, because it didn't just hit 2, right?
Yeah, Voyager 2 did the whole tour. It was like the grand tour of the outer solar system, and we haven't done this since. So Voyager 1 did Jupiter and Saturn again, similar to Pioneer 11, but Voyager 2, Jupiter, Saturn, Uranus, Neptune, all of them, and it's really the only craft, the only robot, as I've been calling them, to visit our ice giants. So Jupiter and Saturn, you think of as the gas giants, and then Uranus and Neptune further out there, cooler, more ices. We call those ice giants. Nothing else has visited the ice giants, just Voyager 2. And so it was really cool. You can see the marks in here where they hit the orbits and then like fling off in another direction. So these are the Pioneers that we're seeing.
These
now,
are our
right?
Pioneers. There's a tiny hint of orange down here that's about to be our Voyagers. But again, we're going to go in 6 months per second. So hold on to your teeth. Here we go. You can see our two new spacecraft blasting off, hitting the orbits of...
There's Jupiter, Saturn.
Jupiter to Saturn.
And then one goes off, and then 2 is still just about to hit
out. Uranus.
Boom. And for the finale, Neptune. And off it goes. So as we have this view now, like you can see, they went off in all different directions from the solar system. So most of them going to what I'm going to call forward, kind of in the direction that their solar system is moving around the galaxy. And then one of the pioneers went kind of backwards in the opposite direction that we're moving around the galaxy. And then for the Voyagers, one kind of went like above the ecliptic, above kind of the plane of the solar system where all the planets are. And then the other one went like below it. So going out in all directions to try to explore like what's beyond our planets. And the two Voyagers have actually hit what we call the interstellar medium, the ISM. And I mean, there was kind of a running joke in like the last decade of like, oh, how many times has Voyager left the solar system? Like, depending on how you define the solar system, because we didn't know it was there. We didn't know where the edge was going to be, so we couldn't really say. And so we had to like go back and be like, okay, yeah, this is the time where this thing changed, and now we can see it's definitely in a different type of zone where we're seeing, I guess, just a different influence with like all these interstellar particles that are no longer being deflected by the sun's magnetic field. So pretty impressive. We're still getting signals from these, even though one of them, I think the most distant one is it's shy of a light day away. I want to say like 19 light hours. So it takes a signal 19 hours to get there and then 19 hours to get back. So if you want to say, hey, that's like almost 2-day conversation. Hey, like,
not that I imagine the Voyagers have too much to say.
Not too much to say. They're not up on the memes. They're probably pretty boring. But I mean, still getting a little bit of information from those as they're plodding along.
Now, we do still have one more spacecraft that's about to join this esteemed fraternity and head out of the solar system. I think we wanted to touch on. Can you tell us about New Horizons?
New Horizons, yes. So this is moving a lot faster. So it got a bigger launch and a bigger boost initially. So it actually got all the way out to Pluto in kind of record time. First thing to actually visit Pluto. I believe when it was launched, Pluto was still a planet, and then it was reclassified. Reclassified en route. It's still a really cool, interesting world. It's still a neat thing. But yeah, so the only thing that we've had visit. I can't say the only thing we've had to visit a dwarf planet. I don't think that's true. But the only thing to visit Pluto, and New Horizons is still pretty close in. It's closer in than the Voyagers or the Pioneers, but it's going fast enough that it will escape. So stop by Pluto and then actually stop by some other objects. And it looks like we have a question.
Stephen was asking, did the Voyager probes detect any micrometeorite impacts as they cruise around, or is space relatively, let's call it, kipple-free?
I don't know about micrometeorite impact detections. I know that we get like micrometeorite impacts around near Earth orbit. Like that's an issue for, Hubble space station and things. But also we have like this big attractor called the Earth in the center of all that. So I'm assuming that if you go through enough space, you'll get some, but I'm not sure what the density is like out there. Probably a lot smaller than it is like closer to like big gravitational attractions like planets.
And if I recall, it had been a big concern when they were designing some of these outward bound missions, but I think the general rate of incidence is lower than expected from what it was in the 70s. So space is pretty empty. So we've got New Horizons right here, just crossing the orbit of Neptune. And again, if we speed up our time frame, we should be able to see this pale blue line is where Pluto is traveling through our solar system. So one last time, let's go 6 months per second. And
buckle up the time machine. Oh, wow. Yeah, I mean, and this thing is going so fast. So then these are flybys. These are not orbits. So it's like you're going super fast. It's like click, 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 like very, very carefully choreographed imaging to capture all the images that we did of Pluto and its moons. There was some serious math happening there. Very, very carefully choreographed photo shoot.
Made the analogy of having to basically thread a needle by throwing the string from across a football field. And that just makes it so remarkably impressive. It really hammers the point home.
Yeah. Yeah, space is hard. Like, I mean, we're showing all these examples of the things that were successful. Haven't mentioned all the all the many failures, all the learning opportunities that we had. So we've gotten a lot better at it. I think, yeah, the success rate has gone up, but it's still far from 100%.
For sure.
So yeah, but New Horizons, off into beyond the orbit of Pluto, well into the Kuiper Belt, and visiting other things out there. So very, very exciting.
Now I think we have a couple minutes left if you wanted to hit one last planet that's had some, let's call it a mixed bag.
Mixed bag. All right. So yeah, Mars early on, really bad success rate. I think it was like 1 in 3 or 1 in 4 for the first couple of decades. Now it's much higher. I think it's closer to 50%. So Mars, very cool. This is our planet that's currently inhabited by robots. So it has multiple orbiters. It has multiple craft on the surface. So a rover, a lander. So InSight is still active. Curiosity is active. And just this summer, because it was like around close approach, we had 3 launches. So we have 3 things expected to show up in February. So there's the Mars 2020 Perseverance rover with Ingenuity. What are we calling it? Quadricopter. Not a drone. It's not a drone.
Not an octocopter, quadricopter, I think.
Quadricopter. But a flying thing on another planet. So that'll be a first. Who is it? The United Arab Emirates sent an orbiter, and I believe China sent an orbiter or lander rover. So like going all out for China's kind of first attempt at Mars. They were just like, we're going to do everything on the first shot.
Rockets are expensive. Do it in one.
So just do it all at once. So very, very exciting. So February will be a super fun month to check out Mars and see how these things arrive, hopefully all in one piece and hopefully all successful.
If folks want to check Mars out, now is a great time to be doing it too. You don't even really need a telescope. It's that very bright red object that's up right when the sun goes down.
Yeah. Close approach is just this week, I think Tuesday, the closest it's going to be for another 1.5 to 2 years. And again, the first thing that we really had flying by Mars, kind of circling back to when I was talking about Mercury, was one of the Mariner missions, and the Valles Marineris, that huge gash was named after the Mariner. So huge gash that you can see, like if you're in orbit around Mars, it's like, how could you miss that?
Right there.
But the contrast, you just can't pick up apparently from Earth. So even with all the maps that we tried to have, all the maps that we have had of Mars, that didn't really show up. And we have a question.
Steven had a question. Is it possible to artificially create an atmosphere on Mars? I too am a big fan of The Expanse, but I think that's somewhat aspirational.
Yeah, if you've read Kim Stanley Robinson's Red Mars, Blue Mars, Green Mars, Red, Green, Blue, yeah, they kind of get into all the different ways that might potentially be able to terraform. I'm still not convinced about generating the magnetic field. But I guess if we have the technology to terraform, we can probably figure out the magnetic field, because that's the issue that I'm most concerned about. Yeah. And even like you mentioned The Expanse, like I was talking about this like in another show like a week or 2 ago, like they talk about like, you know, till the rains fall hard on Olympus Mons, and I'm like, that's not going to happen. I don't care how much terraforming you do. Olympus Mons is too high elevation.
Tall. Yeah, getting rain clouds all the way up there is pretty impossible.
Yeah, maybe some rains down in Valles Marineris. I could see that. That'd be great.
I love the sci-fi fans we've got accumulating in the chat. This is great. Well, Irene, thank you so much for joining us. Is there any parting words you'd like to share with our guests?
I guess just go outside and look up. The sky is free. It's available. Even in light polluted skies, you can see the planets, you can see the moon. And if you can get to darker skies, you can see a lot more. So just encourage people to look up. Don't give up.
Even in our urban skies, there is still a wonderful, beautiful sky hanging out up there. So, Irene, thank you so much. Thank you to the team at Open Space for joining us and helping us share this with more folks. For those of you who are tuning in, if you want to check out the SurveyMonkey link down there, you can complete the survey. The first 30 people get their very own NASA sticker mailed to them. So, by all means, you should follow that and let us know what you think of the software, what you think of the program. But from all of us at Morrison Planetarium, Irene, thank you so much, and thank you to our guests for tuning in. It was a joyful program. Stay happy, stay healthy, stay home, and we hope to see you sometime soon. Thanks again.
Thanks.